Hi, mathematicians. This is Mrs. Shopper coming with special segments in a circle. So here we go. First of all, chord segments. All right. Well, we know a chord connects the outer part of the circles. Chord segments are parts of those chords. The one thing I want you to see here is the relationship between the parts of the chords. When we look at this, so I'm going to scoot in here. We've got that EB times BD is congruent to or equal to AB times BC. Now, what I want you to notice is we can also take this relationship and we can put it into a proportion. We can say that AB is to EB as DB is to BC, because cross products will give us that exact same equation. Cool stuff. All right, so we want to find X. This one's a pretty basic one. 12 times 9 is equal to 8 times X. So 108 is equal to 8X. So X equals 13.5, right? This one, it gives us a little bit more complexity, which is what I love for this course. So what we're going to do is we're going to take the quantity X plus 4 times the quantity X plus 2 is equal to X times the quantity X plus 10. All right. So I'm going to FOIL it. X squared plus 4X plus 2X plus 8 is X squared plus 10X. Cool thing here for you, no quadratics because the X squares cancel out. So 6X plus 8, excuse me, is equal to 10X. 8 equals 4X. So X equals 2. Bingo. All right. So let's look at the relationship between the chord segments. Now, secant segments, all right. So a secant intersects the circle, has at one point. So if two secants are going to intersect at a common point, the product of the measure of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its secant segment. Okay, so what we're saying is AB times AC is equal to AD times DE. Okay, it's the external part times the whole thing is equal to the external part times the whole thing. So if we're going to find X in this case, all right, I'm going to write out the equation. So EH times EI is equal to EF times EG. Okay, so if that's the case, I'm going to fill in what I know. EH is 8. EI is 8 plus X. EF is 10. And EG is 34. Okay, the outside part times the whole thing, the inside part, outside part times the whole thing. So 64 plus 8X is equal to 340. So 8X is equal to 206. 13 minus 276. So then 8 is going to, or X is going to equal 276 divided by 8 is going to be 34.5. That makes sense? 64 plus 8 times 34.5 is 340. That definitely works. Okay. So that's how you're going to use that relationship. The other part we want to talk about is the tangent segment. The segment of the tangent on one end of the circle. So when we're looking at this relationship, it's very similar to what we were talking about before. JK times JK is equal to JL times JM. So you can still think about it in terms of the external times the whole thing is equal to the external times the whole thing. All right. So we can keep that common idea as we're processing through. So here we go. We can say that LM times LM is equal to LK times LJ. And then we can go ahead and fill in our values. I think sometimes that helps us kind of keep this organized a little bit better. X times X plus, there we go. All right. So we've got 144 is equal to X times 2X plus 2. So 144 is equal to 2X squared plus 2X. Oh, now we get to solve the quadratic formula, right? Right? So now we've got 2X squared plus 2X minus 144 equals 0. I'm going to divide everything by 2. So over here, I'm going to have X squared plus X minus 72 equals 0. This one's factorable. I always like to factor if I can. So X plus 9 and X minus 8. And now I use the zero product property to solve. So X equals negative 9, X equals 8. When I'm talking length, I only have one value that can work because it can only be the positive one. If these are both positive, then they could both work. So X equals 8. All right. Have a great day, and we'll chat with you all soon. Bye-bye.